name is Teodora Yuan, and today we will be talking to Cátia. She's an astronomer and manager of ESERO Portugal. Now a little bit of technical ideas. So I am a member of the Space Awareness team at European Schoolnet. I will be moderating the session today. For a few more minutes, we will have here with us my colleague Enrique. You can see him with the Scientix account. So if in the first 10 minutes you are still experiencing technical issues, please write to him in the chat. You can select him as a separate user, so write to him directly and he'll be able to assist you. After he has left, so after these first 10 minutes, you can address these technical issues directly to me, and I will try to help you solve whatever issues you may have. I kindly remind you to please keep your microphone on mute and your webcam turned off, as it'll help us to have a smooth presentation from Cátia, and to make sure that everything goes well. And the presentation will last for about 40 minutes. After that, we will dedicate around 15-20 minutes to your questions. So if you have any questions for Cátia, please write them in the chat. I will collect them, and at the very end, when Cátia is done with her presentation, I will address the questions that you may have for her. And you can also use the chat if you like to share comments, suggestions with other participants. Again, I remind you for the questions to share your ideas with everybody. In the chat, please select the option everyone in the recipient menu so that everyone can see your messages. Now I will leave the floor to Cátia, who will talk about how to implement space careers activity for your students. She has a bit of a cold from what I understand, so please be patient with us. I'm sure it will go fine. Cátia, you can go ahead. For everyone, I will be right here, so you can write to me in the chat.
So hello everybody, thank you for listening to my webinar. It's my first webinar, so thank you for the invitation. I hope everything goes well. So I was invited to present this webinar about space careers because I guess I have a space career. I'm an astronomer, and right now I'm not doing research anymore, but I'm working with this amazing team at Ciência Viva as part of the Portuguese ESERO, and also we are part of the Space Awareness Project. So we have a lot of activities also for teachers, and here I'll be presenting some that are integrated in the space careers context. So I'll start by presenting the structure of this webinar. So I'll give you a bit of my background because it may be interesting also for you to know. And then I'll present 3 topics about the space careers. So we'll talk a bit about the role models, specific activities for the classroom, and what are the pedagogical outcomes of these activities. So, as I mentioned, I'm an astronomer. I did my undergraduate in physics and applied mathematics in Portugal. I then went to the UK and I did a PhD in physics, astrophysics. I also was in France and at ESA in Holland. I did a postdoc in Italy and also in the UK, and now I'm back in Portugal. So for me, being an astronomer, a scientist, is also being a citizen of the world and seeing with different people and different realities that we can all speak the same language, that is science, in this case astronomy. So I think astronomy is particularly important or special in this topic of being a citizen of the world, because we actually have to travel to these very nice places like what we see here in Chile to observe, to have the best skies possible in the world. So you go to the deserts because there isn't water in the atmosphere. It is very bad for astronomy, and we do the observations. So here are some of the places I visit as an astronomer. So this is the very large telescope that is composed by those 4 Can you see the mouse? I think so. So you see these 4 big telescopes. Each one has is the size of has a mirror of 8 meters, and the building is very large. It's almost the size of smaller than a football field, but very large. Then I also was here also in Chile. La Silla Observatory is an older observatory with smaller telescopes, but more telescopes. So here we have over 10 observatories, from different countries. Also in the desert, as you see the background, it almost looks like Mars. And here, I was also here. So this is the biggest observatory in Europe. So this is in Spain, in La Palma, in the Canary Islands. And this is one of the telescopes I use, the TNG. And you can see we are above the clouds. So most of the observatories are located in deserts and in mountains. So they are above the clouds and in very, very dry places. But these are very nice pictures, but in reality, astronomers are not traveling all the time, maybe do 1, 2, 3 observing runs during the whole year, because the rest of the time is spent actually in front of a computer looking at data. So being an astronomer is actually very different from maybe what most of the people think. So we don't look at telescopes every night. We don't look at microscopes like we see here in the image. We are not astronauts. Most of the time we look at data when we program software to do data analysis. At least that's what I did, because I did observing job as an astronomer. So here I'm presenting a bit of what I learned. I was studying brown dwarfs. So brown dwarfs are some of the smaller objects in the universe. They are smaller than stars and larger than planets. And they are born from a protostar, like normal stars, but they are so small they never become a star. So this was what I was studying for years. And actually, this is the job of my PhD. Epsilon Indi BABB is one of the closest brown dwarfs to Earth. And a brown dwarf is very different from maybe what most of the people know. It's a very recent object. It was only discovered in '95, so it's been known for 20 years. And there's a lot of unknowns about brown dwarfs and their connection with planets and stars. But most of the time, I was just looking at plots like this, doing data analysis, or like this. Each point here is a brown dwarf. And what we will discuss a bit here is what will be the future of astronomy and the future of space science. So in the future, we'll be using telescopes like this that is being built, the EELT, the European Extremely Large Telescope. They will have a mirror of 40 meters, 42 meters, if I'm not mistaken. So we are jumping from telescopes of around 10 meters to 40. So it's an increase of four in the diameter of the telescope. That means that we are going to see a much deeper universe. And we'll have larger telescopes, and also we are having telescopes that do whole sky surveys. So they collect a lot of data, really big amounts of data, and they scan the sky continuously. So this means also that we need new infrastructures also in the technological point of view, in the sense of data using and data management, also in astronomy. So in space and also in astronomy more particularly, we have the need of people with a physics background, with a technological background, that can understand and deal with this amount of data. So what we'll present here is a bit what can we do to convince the students, your students, that learning a STEM career, that becoming an engineer or a scientist is something that is good for their future. So, as I said in the beginning, I'll show you 3 topics, but I'll start with the role models, because I think the role models are probably one of the most important things. Because some of the students have never had contact with engineers or scientists, so what the reaction I get sometimes is that, oh, you're a real person. Yes, I'm a real person, and most of the scientists, well, all the scientists and engineers are real people, and they behave as such. So in your classroom, you can use people close in the community to the students to become their role models. And I'll show you later, using scientists and engineers that are from your community has a very large impact in the students. Another perspective is using astronauts. Astronauts are always loved by everybody. Everybody loves astronauts, so it's always a good technique. And of course, other role models, like students that had an interesting path, someone that the students can relate to. And this is important, because if the students cannot relate with these role models, it can actually have a negative impact in the students. So if you someone that they think is perfect and that they cannot relate with, it can have a negative impact. So I'll show you some of the available resources. Some of them are in Space Awareness webpage, so I think you should already know this one. So this is the career page. It's in the beginning, so it's being developed, but you already have here a few examples with an astrobiologist, an astrochemist, and people that design the spacesuits. Also, there's the page with the interviews of these people related to space. Here we have the example of Karen Olsen Francis. But I'll give you other examples outside the Space Awareness. This is another project developed by ESA with using the Team Peak astronaut. So Team Peak was an ambassador for the space careers, and he did a great job because he did a lot of activities related with students. He did activities also related to teachers, and there was a set of materials that were developed, and they are developed in different languages. So here you can see a job profile. It's the job profile of Team Peak. He's an astronaut, and he explains what he did, what he worked, what he studied, what he does in his day-to-day life. So it's something that the students can read and connect a bit with Team Peak. Team Peak was in the military before he was an astronaut. He was a pilot. So it's something they can read and get inspired by. But as you can see, Team Peak was a big success in the UK. He's a British astronaut, but the success that at least we felt here in Portugal was very limited, because I think the connection with the astronaut is also very nationalistic. So we would like an astronaut to speak our language, to speak the same as us, to have the same background, and sometimes that's not possible. Like in Portugal, we don't have any astronauts. So what we try to do when we organize our events is give some thing that the people can connect with. And when we adapted some of the materials, we also invited some Portuguese people to give their professional profile. Like here in the example, we have Celeste Pereira. She's a Portuguese engineer, and she works doing almost clothes for the spacecraft. She does thermal protection material. So I think that's a very important thing. So the students can relate in some level to the role model we are presenting. Another very good example of this role models that are different, because the students will have different backgrounds and will have different experiences. They will also have different tastes. They will like different things. Not everybody will want to be an astronomer. Some of them will want to be engineers. Others will want to be things completely different. So it's important when we are presenting role models that we present them in a diverse way, that everybody feels included. A nice example of this is this exposition sponsored by ESA, It's called Space Girls, Space Women. And I'll try to put play. I think it must be working for you. So this exposition, it's a pictures exposition, but it also has several videos developed. They show women related to space fields, and they show different types of women, from students to high-level researchers to astronauts, and people doing different things. So they actually can relate with a lot of different realities and a lot of different also possibilities. So the idea that this video wants to pass is that space is for everybody. It's for every girl and for every woman. And well, it's very related to women, but I think it transfers the idea that it's for everybody, even for boys that are the majority of people now in the engineer field. An activity that we have developed here in Portugal and has worked very well is called Space Travels to School. We developed this activity during World Space Week, and here Ciência Viva invites engineers and scientists to visit their local schools and present a seminar about their research, about what they do, about their career. And each year we reach more or less 5,000 students. So it's undergoing because we are currently in World Space Week. It finishes today. So I don't have the numbers for this year, but so it's around 5,000 students in almost 100 schools at national level. So what we do here is inviting the scientists and the engineers and the space industry, but what you can do very easily is do the same. You should go to your local university, to the local industry, to the local people that are around in your community, invite them to go to your school and talk to your students, because most of these people will say yes, because as I said in the beginning, they are just normal people, so they will be very interested in participate and collaborate with you. And for your students will be, for some of them, will be the first contact with people related with space, and they can see a different side of space. Because I think most of the students have heard of doctors, have heard of, I don't know, other very difficult disciplines, but they are connected with their everyday life. And space and some of the STEM careers are very hidden in their special reality, and that's the case of space. So bringing people that work in this reality to the classroom, it will give them a reality. So it will make them more real and more approachable. Also, a similar activity you can do is organize trips and visit these research laboratories or the astronomical observatories that are in your city, industry headquarters. I'm sure in your city or nearby you'll have something related with space or with STEM that can be interesting for the students to visit and also to relate to. Also, if you connect these activities with an important date and you explain what you're celebrating, like World Space Week or the International Day of Human Spaceflight in April, it will give historical context and will bring more importance to the activities you're organizing. Most of the countries will have something similar to this catalog that is for Portugal. There is the Portuguese Space Catalog. So if you go to the web page of your space agency or the local space contact with ESA, you'll have access to a list of people that work in the space industry for your country. So I was informed that this exists for most of the countries, so it's just a question of looking for it and looking for these contacts. Especially people in the universities, they are very used to contacting with local schools, not as much in the space industry, but the maximum you can get is a no from them, and I'm sure you'll get more yeses than you think so. So, being more practical and things that are actually already developed for the classroom for your students. And we'll talk about a few of the activities for the classroom. I'll start with the citizen science projects that I know was discussed in the last webinar, and I'll just point two of them. I'm sure you spoke more in the last webinar, so I'm not spending much time here. But this is something that the students can do on their own, and they are actually contributing for science, for a scientific project, because their results will be used by the scientific community. So it's something useful, but it's also something that they will do in an isolated way. So this is a different one. So the previous one was Galaxy Zoo, a classification of galaxies, and this is Planet Hunters. So they will look for transits and look for exoplanets. But I think it's much more interesting for the students to participate in projects that they can do in a group. So this is some of the examples of contests for students in Europe and also at worldwide level. So we have Odysseus 2. There is a contest that invites students to create the concept is a bit different depending on the age of the student, but it can be developing a project or developing an image of a space image. So it depends on the age group of the students, but it's open at European level. We have Mission X. Mission X is a competition worldwide. You can see there all the countries that are participating. It has been having the support of the ESA astronauts. There we see Team Peak was the last ambassador for Mission X, and this year with the flight of Thomas Pesquet, we'll have Thomas Pesquet as the ambassador of Mission X. We have CANSAT in Europe is probably the most complex contest I put here, where the students, high school students, create their microsatellite in the size of a can. So they have to have the components of a satellite, like the battery, the sensors, communication with the ground station, and also the parachute. And they have to develop a mission to study the atmosphere or the ground, or they have to develop their own mission. And it's a project, a team project that is very well established in Europe, and it's very complete also. And we have here a new competition at European level. It's called AstroPi. It was developed last year for Team Peak's mission, and this year we'll have the competition running at European level with Thomas Pesquet. It's just open the application, so feel free to apply also with your students. So here are some of the contests you can do actually with your students, and they can have an active role presenting their projects and building their projects, and actually having like mini space projects and developing all the process of having a space project. A different type of activity are the debates, and here we give 2 examples of debates. So we have been organizing science fiction versus reality debates, where we show a science fiction movie like Gravity or The Interstellar, or most recently The Martian, and then we invite scientists to debate what was real and what is just Hollywood part of the movie. So this is something you can actually do in your classroom, and they can study the movies and try to find the answers on their own, or you can actually invite a scientist and have him debating with you the movie. This is also important to bring a bit of the reality to the debate. So sometimes we see these movies and we are amazed with the science fiction behind it and the stories and the special effects, but actually we are not that far away from the science fiction. Here I put 2 images, one of the Martian, one of the ExoMars. Well, this is an artistic impression, but it's similar to what is happening. And we don't have astronauts on Mars, but we do have robots on Mars, and we have a mission now arriving there in the end of the month that will study the atmosphere on Mars, that will study the terrain in Mars. So we are not so behind the science fiction right now. And it's something interesting to debate in the classroom. A different type of debate is what happened at European level, was the ESA Citizens debate in September. And this is a debate that can be adapted to be presented in the classroom. This debate was organized by ESA in all its member states, and all the resources that were used are available online, and they are translated in all the languages of the ESA member states, so they will be available in your language. And you can actually do a mini debate, adapt the questions, or even use the same questions, and, for example, compare the results of your students with the results of the debate at the European level. So it's something that you can do easily in the classroom and make your students think about it and debate about the future and what they want from space, because space will be for them, will be their future. So it's something interesting for them also to debate. Oh, sorry, I had a video here. I'll show you one of the videos. So this is the invitation video from Tim Peake for the ESA debate.
Hello, I'm Tim Peake, a European Space Agency astronaut on board the International Space Station. Now, one thing you cannot miss from up here is the beauty of our planet Earth.
Can you hear me?
Yes, sorry, Katia, I muted your microphone while the video is playing so that there's no echo.
Okay.
But now it's fine now.
Okay, thank you. So what I wanted to discuss now is the pedagogical outcomes of what I presented here. So so many of these activities you will see, and the discussion we have when we talk about space, it involves a lot of teamwork, a lot of communication skills, a lot of different problems, and so critical thinking and problem solving are very important, and project management. So in any space mission, failure is not possible, because you cannot go as you do in your living room, that the router stops working and you go there and you turn it off and on again and it starts working again. So that's not possible for space. So there's a lot of work in the redundancy, and making sure everything works before it's launched to space. And that involves a lot of work. So when we see Team Peak in space, we don't see just Team Peak, we see the work of everybody that made possible Team Peak being there. Everybody, since the person that designed the rocket, the person that designed the suits, the person that checks his heartbeat because they are always being monitored for their health, the people that cook their food. So there's always a big team behind any space mission. And as we see now, we haven't had many problems and many misadventures in space because that teamwork works. And it's important for the students, and that's what they take out of this competitions or this debate or this interaction with the engineers, to understand the importance of these topics I write here, like teamwork, communication, problem solving, critical thinking. So even if they don't learn much about the technical point of view, as in AstroPi or CANSAT project, they will learn soft skills that are important for their future. Being an engineer, a doctor, or something else, it's always important to have in mind these topics. So I'll show you a small video that shows the importance of the teamwork and what we can take out of it.
Once upon a time.
I'm almost finishing. So I think this story is great to wrap up the teamwork and the way people should work in a team. And just to finish, I would just like to speak about the connection of space world with the real world. And what I mean by that is sometimes it's not obvious the way space contributes to our day-to-day life. And I have here some examples. Let me see if I can share, if I know how to share. So now you're probably seeing my screen. Okay, so here is a brochure of NASA of spin-offs, just from 2016. So a spin-off is something that was developed or not necessarily developed, that was made better to be used in space. And here we see that, sorry, I think I closed it. Okay, no. Okay, should be opening again. So here we see that there's at least 2,000 spin-offs from space to everyday life. And we are talking about developments in medicine and transport, like monitors, health monitors, machines to make sports. That was also developed because of the astronauts in the ISS. Thermal objects, so the way we do thermal isolation was also developed for space. Many different things. It's difficult to isolate them. But here in this magazine, you can have a read through, and it's something that is present in our day-to-day life. Like, for example, food. The way we preserve food is very different because of space. So because of space, we had to develop new technologies to make the food not go to waste in a few months. And that's something that was developed for space. And of course, there's always the satellites that allow us to have communications, and the GPS that allow us to know where we are. And that's the most visible. That's the most visible things. But there are others that maybe we don't know, but they are also present, and they were also developed for space. So this magazine has some ideas. Let me then stop sharing this and see if I go back to here. Here I'm showing you a print screen of an activity book that was developed by the ESERO UK and by the Space Agency of the UK. And here it's a book for careers, about careers. It's called Look to the Future. And as you see, most of the contents and the objectives are focused on problem solving, teamwork, soft skills, something that the students will take with them. It's not just about knowing what are the space careers that they can have, but even if they don't want a space career, they can have more idea of what they want and learn better the skills they have to have for that. So for me, that's it. Do you have any questions? I think I'm on time.
Thank you, Cátia. Yeah, you are absolutely on time, on the minute.
Let me just give you my email, so it's there, cienciaviva.pt. If you have any other questions that I cannot answer today, you can email me. But
thank you, Cátia. If it's okay with you, we can share this presentation with everyone after the webinar. Some participants here were asking for the links to some of the videos and the resources you've shared. If possible, to also maybe put those in the presentation so we can share it as a uniform content piece. And yeah, so don't worry, everyone, you will have the access to the recording and to all the resources that Cátia has shared. And so now I have a couple of questions from some of the participants, and let's see, the very first one, someone was asking if, Katya, you think that, apart from introducing space professionals in class, introducing individuals that participate in citizen science projects, so if they participate quite a lot, if it would be a good idea. So if so, what would you suggest? I mean, would it be helpful to present people that are very engaged with citizen science activities?
I think so. Everything that shows the students a different reality, I think it's good for them because they will grow with that experience. So in the Portuguese space sector is very small. So most of the engineers we bring to the school, they actually do engineering for space projects, but also for other types of projects. So if you're writing a software, if you're an IT person, you can write software that controls a spacecraft, or that controls trains, or that controls air conditioning. So the job you'll choose doesn't need to be related to space directly, because you can end up doing things related to space, or the other way around. You can want to end up doing space things and end up doing something else. So anything that is different and will broaden the horizons of the students, I think it's positive.
Okay, thank you, Katya. Next question is, what would you suggest as a good practice to include when hosting a space career person in the classroom that goes beyond just having the visitor present himself and the children asking questions? So maybe they could work on something together, or very practical, what do you think as an activity is helpful for that role model to do with the students?
I think it depends on the role model and the way he's used to interact with the classrooms, because some will have experience doing so and they will feel at ease doing it. Others will not feel so comfortable. So I think it also depends on the people you're inviting to. So if you invite someone that is very used to, I don't know, maybe doing a citizen science project, or analyzing astronomy images, or something completely different, they will feel comfortable. Others will not. So it really depends of who you are inviting. And it's always good to speak with the people before and find a common ground that it suits the teacher and also suits the person that is presenting. There's no 100% answer to that question.
Okay, so it's all about adapting to the situation. Okay, thank you. Now, Katya, I'm not sure how familiar you are with the idea of a Twitter chat. Now, please correct me if I'm wrong. We have someone here who asked for advice if they want to organize a Twitter chat with an astronaut. And I think it's basically an astronaut saying that he's available on Twitter at that moment to receive questions and to talk to people, i.e. in this context, students, to reply to their questions.
I know that it's very difficult to have video chats with astronauts, and that has to be organized by NASA or by ESA. But I think sometimes they are available for these chats on the social media, and also for chats via radio, via RCs. So I know some schools do those kind of projects, but I'm not very familiar with, so I don't think I can help much.
Okay, no worries. For those of you that are curious about hosting such a Twitter chat, we will look into it and we'll see what kind of resources maybe we come up with this, or hopefully in the near future of the project we'll have some ideas for this as well. Now we have one other question. So there is someone here who acted as a role model in the past, and they'd like to know, how would you answer students when they ask if you can get a job after a PhD, knowing that there are supposedly very few positions in science? So how would you approach?
The academic system is a pyramid, right? So you have many more PhD students than you have positions at the end. So not all the PhD students will end up in an academic path, and I think that's also good, because you cannot have everybody doing a PhD end up as a professor because there's not enough available places in the university. But I think a PhD is valued in the workplace. So a PhD brings you qualities and it brings you competences that you have acquired because you have done a PhD. So these competences are useful in doing a different thing. So I have a PhD and I'm not an academic anymore, so I'm not doing research, but the skills I've learned during my PhD are very helpful for the work I'm doing now. So everything you learn during your life is important, and it will bring you an extra advantage when you're looking for a job. So I think you should just be honest. Not everybody that does a PhD will end up as a professor in an academic track, but it doesn't mean it will be less or more successful. It just will have a different path.
Okay, thank you, Cátia. A very delicate answer to a very delicate question. Okay, we have...
yeah, I've done that, so I don't feel that I lost anything because I moved away from academia. Actually, I think I've earned it because academia was not for me, and when I saw that, I preferred to do something else more fulfilling for me. And I think that happens with a lot of students that do PhDs and then realize they don't like the academic style of life because it's very competitive. It's very difficult. Sometimes people don't have that idea, but being a scientist is very competitive. So there's other jobs that maybe they are as competitive, but that can bring more satisfaction depending on the person and what they like to do.
Thank you, Cátia. And now we have two last questions here. So one, very briefly, someone is asking if they can have a Skype talk with you, Cátia, and their students. Yeah. Voila. So you have your question, and Cátia has her email there. So Cátia, I assume they can feel free to contact you for something like this. And also someone else is asking if you have ideas or advice for applying what you've just presented for low-income schools. And I will extend this question a bit, as I know that some of the participants here are also working with students from very different cultural backgrounds. So also, Cátia, if you have any ideas on this. So on applying this advice to like students from various backgrounds of social, economic, cultural, so maybe low-income schools and so on.
So some of the things are easy to organize without having financial help, like the debates. You can invite a researcher to just do a webinar via Skype, via web. So we have organized a few like that, and we will be organizing more using the Pload. So it's an IAU network for the Portuguese-speaking world. So we are collaborating with that, and I'm sure if you contact similar research institutions, maybe not in your country, but in different countries, and you say, can we have a webinar with you instead of a real physical visit to your school? Many of them will say yes, and so I think the webinars is something that you can do with not that many money. The rest of the activities, I'm trying to think. Well, CANSAT and AstroPi, you need the resources, but like Mission X is something that is spread all over the globe, and you don't really need many resources. The activities are available online, and they're actually very easy to do in any classroom in any place in the world, because most of them are physical activities and activities related with food. And so I think Mission X is something that you can check for also activities that are easy to replicate in the classroom. I think that's it from me.
Okay, thank you, Katia. Now I was checking the chat. I haven't seen any questions coming in recently. So Katia, thank you very, very much for your time and for this precious advice you've shared with us. For everyone else here, as I was mentioning, you will have access to the presentation, to the resources that Katia has presented, and the recording of the webinar in the following days. For those of you that are participating to the Space Awareness MOOCs, you will see the recording uploaded in the respective section of the MOOC. If not, you can always access the Space Awareness website, the Career Hub, and then there you will find everything else. Now, just a little bit of news for next week. We will have on, let me see exactly, on the 17th of October, the next Space Awareness webinar, also as part of the Space Awareness MOOC. This webinar is with Mr. Frank Dainty from ESA. He was head of human resources, and he will talk about space careers, so just like Katia has done, but he will talk from the perspective, from the industry perspective. So I invite everyone here to watch our social media channels for when we have more information about the webinar, so that you can register and participate. And I think that's about it. Katia, I see you have a lot of thank yous here, so thank you as well. And I will see everyone soon. Have a nice evening, everyone, and thank you for participating.
Thank you. Thank you, everybody.